I'm so excited for today. We get to do finding the area between two curves now. This is an application of integration, so just more of the same, but just in different ways. And I really like it. So let's do this. This one says graph the function f of x is equal to, and we've got this function, this parabola. So what you can do is on a graphing calculator, go to y equals, and you want to graph this function, so negative 1/2 x squared minus 2x plus 4. And we know it's a problem. We know it's going to be upside down in some way. So like this way, because I know my first term is negative. But what you can do is go to table, and I'm going to pick some values. So let's say at negative 8. I'm going where x is negative 8. And I see I have negative 8, negative 12. That's not on my graph. What about negative 7, negative 6.5? Sure it is. So I'm going to put this over here slightly. So negative 7, negative 6.5. I'm just graphing some points off of here. Negative 6, negative 2. Negative 5, 1.5. Negative 4, 4. Negative 3, 5.5. Negative 2 is 6. Oh, that's nice. We can kind of see where the vertex is going to be right now because we've got another one at 5.5, 0, 4. Oh, look at this, so pretty. 1, 1.5. 2, negative 2. And then 3, negative 6.5. So this is the graph of f of x, and I'm going to make this nice. I didn't want to say anything too soon, but that is a nice looking curve. Okay. And then it says, so graph this function and find the value of this integral f of x dx. Okay, so if I think about what does that actually mean, so even without looking at my graph, well, right now this is a graph of f of x, by the way, but I could find the area under the curve, or could I? That's a weird shape, so I can't do it that way. So if I don't want to do the area under the curve, what I want to do then is think about what is the fundamental theorem of calculus. So I would integrate this. So I would add 1 to my exponent, divide by my new exponent, and I get 1/6, negative 1/6 x cubed minus, this would be x squared plus 4x. Then I can evaluate from negative 5 to 0. If I substitute in 0, I get 0 minus 0 plus 0. Here it gets a little bit trickier because I'd have to subtract negative 1/6, negative 5 to the 3rd power minus negative 5 squared plus 4 times negative 5. And then I would have to do some work, but if I just use my calculator also in here, because I want to, this would become negative 1/6. I'm just substituting everything in, so negative 5 to the 3rd power minus negative 5 squared plus 4 times negative 5. I get 24.166, or you could say 0.167. Or I could say, if I change this into a fraction, 145/6. And you might say, well, if you're going to use your calculator anyway, why don't we just go to math 9 and integrate from negative 5 to 0. For my function f of x, I would put in my actual function, so negative 1/2 x squared minus 2x, sorry, I almost pushed plus, minus 2x plus 4, don't forget your dx over here, and I should get the same thing. Hey, I did. So either way is fine. Okay, so we did all this work integrating, and then we're like, what does this mean? Using one color, I'm going to choose pink. Shade the area this represents. And so if I'm thinking from -5 to 0, so -5 to 0, remember how we did this before? We made a horizontal line. We go up or down on the left till we get to our function. Same thing over here. I'm going to go up or down until I get to my function. So if I'm shading this, I'm going to be careful because I'm shading with pen. So I'm going to make mine. This is the area that we just found. It was the area of f of x. But when I say under the curve, what I actually mean is the area between f of x, the function, and this line y equals 0. So I've got the x-axis. That's what I'm talking about. Just this shaded region. That's what I just found. And if you're like, I'm not exactly sure yet, you could do one more really cool thing. Remember how you can do the integral here? X squared minus 2x plus 4. I'm going to change my window so it looks like this, -8 to 8. I'm going to go -8 to +8. If I graph this, oh look, it looks like the same thing. And if I do second calculate, and I go to the integrate, which is number 7 here, and I'm going from -5 to 0. So pretty. That's what we have. So I'm hoping that you are convinced by now. Okay, so we did all of that work. And by the way, that's the same thing, 24.166. There it is. Same thing we got. All old stuff. Let's keep going. Now it says graph the function g of x is equal to 1/2 x plus 4. G of x is equal to 1/2 x plus 4. So I'm going to go up 4, going up 1, right 2, up 1, right 2, up 1, right 2. Or I could go down 1, left 2, down 1, left 2, down 1, left 2. On the same grid. So I did this. I'm going to make my line. These lines are so good. I'm winning today. Then to find this value. So you can do this one of two ways. You can say, you know what, I'm going to find -5 to 0. This is of g of x dx. And I know this is equal to -5 to 0. G of x is 1/2 x plus 4. You could find the area under the curve, because I can see right here from -5 to 0. Do you see how I have a trapezoid? Or you could say, you know what, I don't want to do that. I want to do fundamental theorem of calculus. I'm going to add 1 to my exponent, divide by my new exponent, and I'm going to evaluate this from -5 to 0. That's okay too. Either way, you're going to get the same answer as long as you do it correctly. So I'm going to substitute in 0 and 0, and I get 0. If I subtract, -5 squared is 25 over 4, 25 over 4, minus 20, this would be 20, -20. This would be -25 over 4, plus 20, which is the same thing as 80 over 4. If I add these together, 80 minus 25, well, 75 minus 25 is 50, so this would be 55 over 4. Or you could say, you know what, I'm not going to get rid of this entirely, but this time I'm going to do integrate, what did we say this was? 1/2 x plus 4. If I graph this, hey, it looks like mine. Second, calculate. And I'm going to integrate from -5 to 0. This is what they just did, was find the area under the curve. This is 13.75, which should be the same thing as 55 over 4. Whoa, there it is. Hey, it's the same thing. Okay, so what we did is 13.75. But then we have to use, it says using a different color, shade the region for which this value represents. Well, we kind of did this already. We went from -5 to 0. If I go up and the left and the right, this would be this region. So it'd be this stuff down here. And then I want to know, what do you suppose you would do to find the area of the region that's located between the graphs of f of x and g of x? So what region that is, I wanted to find this region, so the area up here, what do you think I would do? Well, I would take the total area and subtract this area. So what we're really doing is we're taking that total area, the -5, 0, f of x dx, and we subtracted -5 to 0, g of x dx. Because that whole region was the 145/6, what we got up here. This region I knew was 55/4. And then if I subtract these, 145/6 minus 55/4, I get 10.4167, or I could say math fraction 125/12. And really this is approximating since I rounded to the end. Well, I truncated. Oh, my face is in the way. There we go. Okay, so the bigger region minus the smaller region, I got the area in between. Okay, hopefully so far so good. I'm taking like what you probably learned in middle school, and then we're just like calculus. I was going to say calculusifying, but that doesn't even make any sense. And then I thought of calcifying, and I was like, no, we're not doing that either. So we're just putting some calculus into it. That's what we're doing. Let's do some more. So if we go to the next page, so on 212, it says, now find the value of the definite integral below. If f of x equals this, so that's what we had originally, and we had this. So now we're just kind of playing around with this and just saying, you know what if I was just given this function and I said this definite integral, and I didn't integrate each one of these first, what if I put them all together? And I said f of x, which was -1/2 x squared minus 2x plus 4, and I subtracted 1/2 x plus 4, and I'm integrating this whole thing, but I'm going to simplify first. What if I did that first? What would happen? Well, this would still be -1/2 x squared. -2x minus 1/2 of x would be -2.5x, or -5/2x. 4 minus 4 would just be 0. So I have this. And then I think, okay, well, how can I solve this? Well, you could do the area under the curve for this new function, or you could do the fundamental theorem of calculus. Means I integrate, add 1 to my exponent, divide by my new exponent. So my new exponent is 3. 2 times 3 is 6, so I have -1/6. And if you weren't sure about that, you could always multiply and get -3/6, which is the same as -1/2 x squared. Add 1 to my exponent, divide by my new exponent. If you're not okay with this part, make sure you stop this and think, okay, what did I do? How can I integrate? I'm going to evaluate from -5 to 0. So you're going to substitute in 0, and you would get 0 minus 0. Substitute in 0, 0. If you put in -5, I would get -1/6, 5 to the 3rd minus 5/4, -5 squared. Oh man, and now I'm going to use my calculator anyway, because I don't want to do all that right now. So I have -1/6. This would be, hold on, I forgot to put, there's a negative here, but there's also a negative there. So -1/6, 5 cubed, -5. Oh man, me and my negatives right now. Sometimes you have to remember to be negative. How can I be when I'm doing calculus? Okay, anyway, -1/6, -5 to the 3rd power, minus 5/4, -5 squared. And I get, oh, that number looks familiar. Which is the same as math fraction 125/12. What? Isn't that what we got before? Okay. So what do we notice? This was the same as previous problem. This is the same solution. So if we want to find the area between two curves, we do not have to integrate the first function and then integrate the other function and subtract. That's what we did over here. We integrated f of x, we integrated this other function g of x, and then we subtracted. What we can do instead is we can integrate from a to b, so some value, whatever they stop, wherever they end, wherever this intersection is, and we can just say the top curve minus the bottom curve every single time. So we can put this f of x minus g of x. You can say it like that, but just think about when you're saying top minus bottom, what are you talking about? Well, like look down here. The function that looks like it's on top is the top. The function that looks like it's on the bottom is on the bottom. Just take the top function minus the bottom function, integrate that. What you're really integrating is the distance between every one of these places. And when you integrate distance, you get area. The thing about this is this answer should always be positive now, even if I'm below the x-axis, because we're taking the distance from here to here, and that won't be negative. So now any area between two curves is going to be positive. Okay, this says find the area of the shaded region R that's bounded by this. Oh, and I should say the reason why things before by anything below the x-axis was negative is because the top function was really 0. So we're taking 0 minus that function. Just fun fact. Okay, but we've got this area where we're trying to find, and you just have to figure out which one's which. So if you didn't know automatically by looking at this that this was a sine curve, and you're like, oh, that's nice, it's kind of going up and down and whatever, and you weren't really sure of that, the way that you can do that and check is if I graph both of these. And I say sine of pi x, make sure your calculator's in radians, and I'm going to change my window to be what they have, so 0 to 2 and -3 to 1 for my y values. And I'm going to go back to y equals, and my y2 I'm going to actually put in this x cubed minus 4x, and I graph it. I should have something that looks really similar to the graph I was given. Oh, it does. It's like a pretty little bird. Does it look kind of look like a little bird? I remember going to like this carnival when I was like really little at my school, and they had these little bird whistle kind of things there. Oh, good memories. Anyway, if you don't see a bird, whatever, keep going. Or some crazy looking lips that are on the side. I don't know. Whatever you want to be. Back on point. If you use this arrow key, if you push trace, and you see how I can go up and down and the function value changes, you can see that first function is sine of pi x. The one on top is sine of pi x. Down here would be the x cubed minus 4x. So you can tell the difference between them. What you need to know is where's my starting place? Where's my ending place? These ones are nice because the intersection's already given to you. There's sometimes where you're going to have to do second calculate, intersect, the first curve, the second curve, and you'll see where's it going to come together. Oh, no sign changes because I'm not quite far enough. I'm going to make my x min -0.1, x max 2.1. It will sometimes say no sign changes if you can't see the place of intersection or if it's on the endpoint. There you go. So I second calculate, intersect. Hey, I can see this intersection is at 2, 0. Second calculate, intersect again. If I do first curve, second curve, and then when I guess and I have my cursor, I'm going to move it closer to that first point of intersection. Still going, still going. I can see it's at 0, 0. So this one's actually exactly like what it looked like. There's sometimes though when you have to be really careful about that, about where that intersection point is. Okay, so to find the area of this region, I would go my integral from 0 to 2, and you integrate the top curve minus the bottom curve. We said this top one was sine of pi x. The bottom curve, be really careful about how you write it. It is not x cubed minus 4x dx. This isn't enough. This is, well, kind of. This whole thing would be in parentheses. And now this is just a calculator problem. If you do this, if you have an older calculator and you need to do it on this screen, you actually have to do each one of these integrals separately. You would have to do this integral, this integral. You can't, there's not a way that your calculator will do this between the two curves, unless maybe you have the Inspire or something, and then I bet it's fancy like that. But what I'm going to do is go back to the main screen, and I'm going to do the integral 0 to 2. And I'm going to do sine of pi x minus, don't forget parentheses here, really, really important, x cubed minus 4x, close parentheses. I can see my other parentheses are already closed. Whoa, that's crazy. You get 4. I could take the antiderivative, and if you did that, you'd end up using your calculator anyway. But the antiderivative of this, just as a fun fact, what would that be? Okay, you're at negative cosine pi of x. But you would also have to divide by pi because it's a chain rule, but backwards. Okay, but we don't even really have to do that. It's just a fun fact. Okay, so I get 4. Boop, boop. We did it. So how do you find the area between two curves? You integrate the top function minus the bottom function. That's it. Easy peasy, lemon squeezy. And if it's difficult, lemon difficult, let me know. Let me help. And yeah, because you can do this. I'm confident that you can. Thanks so much for learning, for working. I appreciate you. Bye.